Are you confused with these different data stores in Microsoft Fabric, like the Lakehouse, the data warehouse, and the KQL database? And then you could be also wondering, how are these different data stores related to OneLake? Don't worry, since that is exactly what we are going to cover in this video. Welcome to the video. My name is Aleksi, and on this channel I cover Microsoft Azure and Fabric related topics. In this video we are going to dive into Fabric's data stores and explain what are they all about and how they are related to OneLake. The goal of this video is to give you an overall idea about these data stores without diving too deep into technical details. Also, this video is part of my Microsoft Fabric data engineering series, and if you would like to check out the other videos in this series, the link to the playlist can be found in the description. But now, let's get started with today's topic. Let's first start with the Lakehouse, which is a very flexible and scalable data store in Microsoft Fabric, and in my opinion, the most essential data store for data engineers to learn. The special thing about the Lakehouse is that it can store data in multiple different formats. The default format for structured data in the Lakehouse is Delta, which is very scalable and efficient data format for structured data. Lakehouse can also store semi-structured data like CSV and JSON files, which make this data store to be a very good landing or staging area for Fabric data platform, since files can land there and then can be processed into more structured formats. Also, since Lakehouse supports files, it can basically store any kinds of files, so it welcomes unstructured data as well, like image and video and audio files. And then these files can be used from the Lakehouse for some special use cases. Typical use cases for Lakehouses include things like data exploration and reporting that are very traditional use cases for data stores and databases. Also, Lakehouse is very well suited for more advanced use cases like data science and machine learning and AI. Now let's summarize few key points about the Lakehouse before exploring it in Fabric. Like discussed, Lakehouse can store files and Delta tables, which then makes it a very versatile data store for many different use cases. And since Lakehouse is so versatile, it can be used in any layer of the Medallion architecture, but it is especially suited for silver and bronze layers. The main interface when accessing data in the Lakehouse is Spark via notebooks in Microsoft Fabric. With Spark, data engineers can interact with the Lakehouse using one of the 4 supported programming languages, which are Python, SQL, Scala, and R. On top of the Spark interface, Lakehouse has also TSQL interface. But this is a read-only interface, which means that it doesn't allow manipulating the data. Another cool feature about the Lakehouse is the possibility to create shortcuts to other data stores in Fabric, like data warehouses and KQL databases. But even cooler thing is that these shortcuts are not just limited to Fabric data stores, since they can be created to external data stores like Azure Blob Storages and even data stores outside of Microsoft ecosystem like AWS S3 buckets and Google Cloud Storages. These shortcuts allow bringing in Delta tables or raw files to Lakehouse without physically copying the data to the Lakehouse. So basically these shortcuts are like these pointers to these external data stores, but it still looks like that this data is actually in the Lakehouse even though it's not. Next, let's hop into Fabric and let's check out Lakehouse and its different features a bit more closely. Now I have the Fabric open here, and let's open an existing Lakehouse that I have already created. And here I have my Lakehouse. As we can see, we have table section and we have file section in this Lakehouse. Let's first start from the file section. This is a section where data engineers and other users can store raw data files. So basically this file section allows storing all kinds of data. Under this root folder, we can see that I have few CSV files in this Lakehouse, and then I have a folder here, and then I have another folder called Data Lake. But this Data Lake folder is a special one, and you can see that tiny icon there that indicates that this is a shortcut. Data in this folder is not actually in this Lakehouse. It is actually in the blob storage in Azure. But I have just created a shortcut to that folder, so I'm able to see this here in my Lakehouse. But we can navigate the data like it was here in our Lakehouse, even though it's not and it's in Azure. Next, let's look at the table section in our Lakehouse. And under this tables folder, I have a bunch of different tables that I have loaded into this Lakehouse. We have, for example, this game info table, and when we click it, it will open this data preview that will take a moment for the data to load up. And here we can get the top 1000 rows of that data that we can just preview here quickly. Also, I have created some shortcuts to this table section as well. As you can see, some of these tables have this little icon on their left top corner, which indicate that these are shortcuts. Basically, these three tables here are shortcuts to data warehouse tables, and this docs table is shortcut to KQL database table. So by using these shortcuts, I can bring in different tables from different databases in Fabric to this one Lakehouse, and I can access them via this interface. The most native way interacting with the Lakehouse is using Spark, and Spark can be used easily using notebooks. And here we have this button Open Notebook, and here we can select existing notebook or a new notebook. Now I will click a new notebook, and this will create a notebook for us that would allow us to query and read data from this Lakehouse. But yeah, we're not going to cover notebooks in that detail in this session, but this is the way how you would query these tables here. Next, I want to show you the TSQL interface that is read-only, but can be used to query these Lakehouse tables. One way to access that interface is here on the top corner, and here we can select SQL Analytics Endpoint. And this will open up this new view that is basically the data warehouse view here in Fabric. But now this is pointing to that Lakehouse. And with this interface, we could query these tables using TSQL. And since we have this TSQL interface, it means that we can access this Lakehouse using some traditional tools like SQL Server Management Studio. And now I have the SQL Server Management Studio open, and we can see that the Lakehouse is available here, and we can see those same tables here. We cannot see the files, but we can see the tables. And now we can try to query one of the tables like it was an SQL database. For example, we can select top 100 rows from the game info table, like this, and it returns the top 100 rows. But like described, this is a read-only interface, so if we try to run some update commands to that data that would actually modify the data, we will get this error that data manipulation language statements are not supported for this table type in this version of SQL Server. I hope you now have an idea what is the Lakehouse in Microsoft Fabric and how it can be used. Next, we have a data warehouse. That is basically your traditional data experience in Microsoft Fabric. This data store only supports storing structured data, which is organized to schemas and tables, like in many other relational databases. The main use cases for this data store include things like data exploration, data modeling, and reporting, which are very traditional use cases for relational databases that are optimized for analytical purposes. Of course, data from the data warehouse could be used for more advanced analytics as well, but in my opinion, Lakehouse would be a better option for those use cases in Fabric ecosystem. Next, let's look at few key points about this data store. Like said, this is a data store for structured data, and in this data store you can find your familiar database objects like tables, views, stored procedures, and so on. Because this data store is for structured data, it is most well suited for silver and gold layers in the medallion architecture, which means that it's not well suited for bronze layer since it can store raw files or raw data in semi or unstructured formats. However, Data Warehouse has better modeling capabilities than Lakehouse, and that's why, in my opinion, it is more suitable for gold layer than Lakehouse in some use cases. The main interface interacting with the Lakehouse is the TSQL interface. However, data warehouse tables can be linked to Lakehouse that allows them to be read using Spark as well. But the TSQL interface is the main interface for using the data warehouse. The TSQL used in this data store is not exactly the same TSQL used in your Azure SQL database or in your on-premises Microsoft SQL Server database. This TSQL is more closely related to TSQL used in Azure dedicated pool that used to be known as Azure SQL Data Warehouse. I'm not going to dive too deep into differences between these two TSQL variants, but it's a good thing to note if you are thinking about migrating workflows from some other TSQL-based database to Fabric's data warehouse, that your TSQL code might require some adjustments depending on your source data store. Also, since we are using TSQL interface, this allows way more security options for the data that are typically available in traditional SQL databases, like object, column, and row level securities. At this current state, these security features are one of the best advantages that the data warehouse has over the Lakehouse in Fabric. Now let's go back to Fabric and let's check out the data warehouse a bit more closely. Now I have the Fabric open here, and let's open a data warehouse that I have already created to this workspace. And here we have the data warehouse view open, and we can see that this is very similar looking to that SQL endpoint that we had to our Lakehouse. And here we can see how the data is being organized in this data warehouse. So basically we have the schemas folder, and under that we have the schemas available here. And under those schemas we have some tables. Here I have just 3 tables: dim customer, dim product, and fact sales. Now let's check out some features that we have here in the data warehouse. Let's start with the queries. Basically, we can just create a new query here and start querying the data that we have here in the data warehouse. And this is TSQL that we are writing here. So basically, we could write our select statement and select everything from the table dim customer and run that query. And here we have the data set that the query returned. Next, I would like to show the visual query that is a new feature here. We can click this new visual query here. And now we can drag and drop some tables here. And here we can build these queries using this visual tool. And this visual query tool would allow us to create queries using this visual interface. But on the background, it is generating SQL. As we can see, here is the statement that it generated when I dragged and dropped that table here. We could actually drop another table here, and then we could, for example, start to combine these queries together and select some joins that we would like to perform here. But yeah, this seems to be a really cool tool for developing some new SQL queries. Then we also have this data modeling feature here. We can open that up. I have already created this sales data model using those 3 tables that I have there and created some relationships with these tables. But yeah, you could basically build your data models using this tool. Also, since we're using this TSQL interface, we can access this data warehouse using SQL Server Management Studio like we did with the Lakehouse. And now again, I have the SQL Server Management Studio, or SSMS, open here, and now we can check out the warehouse here. And we can see that we have those 3 tables here as well, and now we could query those tables. We can first select everything from the fact sales, and now we can actually manipulate the data, since this is not just a read-only TSQL interface, it is a native interface that allows us to interact with the data. So we can insert a new row to fact sales. And the statement went through fine, and now we can check out that new row in that table. Now we have this sale ID number 4 here, and then we can delete that row from that table. But basically with the data warehouse, you can manipulate the data using TSQL rather than just read it like with the Lakehouse. Next, let's check out the KQL database. This database stores data in tables that are a bit different to traditional database tables, since these tables can store data in structured, semi-structured, and unstructured formats. The feature that makes it possible to write semi- and unstructured data to these tables is that the data structure or schema does not need to be fixed, and the data structure can vary, and the data type for a given table and column can be dynamic. These special features of the KQL database makes it suitable and optimized to very specific use cases. In many cases, KQL databases are used for streaming data that is arriving to the database almost constantly. Good examples of this kind of data are log and telemetry data that are generated constantly. Then this data can be used from this database for data exploration like from any other database. But one of the most typical use cases for KQL databases is monitoring, since it is very well suited for event-based data streams that need to be monitored with low latency. Also, it is possible to do some reporting using data in KQL database with analytical tools like Power BI. Next, let's summarize some key features of KQL database. Like discussed already, this is a data store for structured, semi-structured, and unstructured data. However, the capabilities for unstructured data are not as flexible as they are in the Lakehouse. Since KQL Database does not support storing raw files, so adding some image, video, or audio files to KQL Database would not be possible in the same way. Data in the KQL database is organized into schemas and tables, which reminds a lot of traditional databases. The main interface for using the data in the KQL database is KQL, which stands for Custo Query Language, which is quite easy to learn and low-level query language and reminds a lot of SQL. It is also possible to interact with KQL database tables using Spark. On top of these two interfaces, there is also very limited TSQL interface that is read-only and can be used to querying these KQL database tables using TSQL. This database is designed to store event-based data, and schemas for incoming data can be flexible, and this database supports schema on read, which means that the schema or structure of the data can be defined when querying it and not when writing it. Because of these special characteristics of the KQL database, it is most well suited to some specific use cases like ingesting data streams, analyzing time series, or geospatial data. Next, let's again open up Microsoft Fabric and let's check out the KQL database there. Now we are back in Fabric and let's open up KQL database that I have already created here. And here we have the KQL database view. And as you can see, I have two tables here, IoT and stocks. Both of these datasets are actually this sample data that can be brought to this database to try out the features here. And you can get those basically by clicking this get data and sample here. And here you have the options for the data that you could be using. So you could add some data here and start practicing your KQL skills. But yeah, like with the Lakehouse, this database also supports shortcuts. And I have already created one shortcut here. And this shortcut is actually pointing to my Lakehouse. So this is the same game info data that we already looked earlier. But now I have created the shortcut for that data to this KQL database, even though this game info is actually in my Lakehouse. Also, KQL database supports these materialized views that would allow you to optimize your queries when using properly. But like said, the best interface interacting with the KQL database is of course KQL. And we can, for example, query this table and show top 100 records. And this will create us the KQL statement used for that. But like we went through, there is also a TSQL interface that we can also use, and under this query table we can find this SQL and select this show any 100 records from that table, and this will create an SQL statement and query those 100 first rows from that IoT table. Also, this IoT table is an example of a dataset where the schema is not fixed. As we can see, the column type for this raw data is dynamic, so we haven't specified the schema when writing the data in. But yeah, this KQL database is meant for these very special use cases when you want to have mainly these event-based data streams coming in and writing this data to this KQL database with low latency, or you have a bunch of time series data and you would like to perform some analysis on that. Next, let's cover OneLake and how these different data stores are related to it. But before we do that, I would encourage you to hit that like button if you have learned something new and subscribe to the channel for more Microsoft Fabric data engineering content. OneLake is this one single data store that comes with Microsoft Fabric, and there is only one OneLake per one tenant. OneLake can be thought as SaaS or software as a service version of Data Lake that is being managed by Microsoft on the background. All the different data stores in Fabric store their data to OneLake, which means that in OneLake there could be multiple data warehouses, lakehouses, or KQL databases that store their data to OneLake. Under the hood, all these different data stores use Delta tables as their default data format. Which means that even though these different data stores feel quite different, the data underneath uses exactly the same format, even though interfaces accessing that data could be different. On top of the OneLake, we have a compute layer that makes it possible to access data in OneLake using these different interfaces that we have covered in this video. With these different interfaces, users can access the data in OneLake using their preferred interface, which makes OneLake a very versatile data solution for different skill sets and data needs. Next, let's cover a few key takeaways about OneLake. Like said, OneLake is a software as a service version of Data Lake, and it's built on Azure's Data Lake Gen 2. OneLake uses Delta tables as default data format, which makes it very scalable and efficient data store. Also, OneLake integrates well with analytical software within Microsoft ecosystem like Power BI, Databricks, and Azure Synapse Analytics. The goal of the OneLake is to be one drive for data and eliminate data silos that organizations tend to build over time. And when speaking about one drive for data, OneLake can be accessed from a local computer in very similar fashion than OneDrive. That will be demoed shortly. Also, data security and governance are key features and top priorities in OneLake. Next, let's demonstrate how OneLake could be accessed from a local computer and how these different data stores are storing their data in this OneLake. Now I have my file explorer open here, and I have installed this OneLake application that makes OneLake to look like OneDrive here on my computer. As we can see, I have this My Workspace folder here in the root of this OneLake, and this is basically the workspace that I had open here in the fabric. So we can click what is underneath this My Workspace folder. And we can see 4 folders. There is 2 lakehouses and 2 data warehouses. The KQL database is not yet available, and I'm not quite sure if it will be available here, but for now we can access the data in Lakehouse and data warehouse using this OneLake Explorer. Let's first start from our Lakehouse that we used in this video. Let's open the folder, and we can see that we have 3 folders underneath this folder. There is files, table maintenance, and tables. I think this table maintenance is some type of optimization folder that is still empty, but underneath the files folder we can find those files that we looked at in the Lakehouse section. Also, if you remember, I created this shortcut to Azure Blob Storage, and this was that Data Lake folder that we have here available. So we can navigate through this folder and we can find this file that is actually stored in Azure and not in our Lakehouse. Also, it would be possible that this shortcut would have been created, for example, to Amazon S3 bucket or maybe to Google Cloud Storage. It would show up the same way here, and that is very cool in my opinion. Next, let's go back and let's check out the tables section. Here we can find those tables that I had in my Lakehouse. Let's, for example, open up the game info folder, and here we can find that this game info is stored in Delta format. So we have the Parquet file here and Delta log underneath, and this is the default data format that the OneLake uses, which is Delta. Next, let's go back to My Workspace and let's check out the data warehouse that we had here. And underneath we can find the table section, and here we can find the DBO schema, and under this schema we can find 3 folders that are representing our tables in that data warehouse. Even though we have that TSQL interface that reminds us a lot of this kind of a relational database, these tables are also stored as Delta tables. So basically these tables are using exactly the same format as the Lakehouse tables. Meaning that even though, like discussed, the interface is different, but the data is still Delta. Everything is Delta in here in OneLake, except some raw data files. And also one thing to note about this root folder, that if I would have an access to some other workspaces, they would show up as folders here and I would be able to navigate to data there as well. But now I have only access to My Workspace and it is here. Cool. I hope you now have an understanding what the OneLake is all about and how these different data stores are related to OneLake. If you'd like to learn more about Microsoft Fabric, please check out this video next. Now I thank you for watching and see you in that video.